you see the end results of a crash and look at the evidence that's on the road, look at the evidence that's the vehicle, and try to piece together, the events, what led up to this crash, and come up with the positions of impact, the speeds of the vehicles, the approach of the vehicles. So it's like solving a puzzle using your background in physics and math and training in accident reconstruction.
Today, I'm fortunate to have Steve Grundhoefer as a guest. Steve is a licensed professional engineer. He does traffic accident reconstruction, has extensive experience doing what we call forensic work. He is ATAA accredited. He's crash data retrieval systems operated certified. He started off working as a civil engineer in road design, and then he went into the forensic world and started doing accident reconstruction. He did it for another company for quite a while, and then he started his own business. This is After the Crash. I'm attorney Dave Craig, managing partner and one of the founders of the law firm of Craig, Kelley Faultless. I've represented people who have been seriously injured or who have had a family member killed in a semi or other big truck wreck for over 30 years. Following the wreck, their lives are chaos. Often they don't even know enough about the process to ask the right questions. It is my goal to empower you by providing you with the information you need to protect yourself and your family. In each and every episode, I will interview top experts and professionals that are involved in truck wreck cases. This is After the Crash. Welcome. I really appreciate it. Steve and I have had opportunities to work on many cases together. And in fact, we spent 3 days here recently in the cold and rain out doing a reconstruction. And then on the other hand, I've had the occasion to work with Steve, who was on the opposite side of me. Let's just start off talking a little bit about your background and okay, if that's important and why is it important? You have a bachelor's degree in civil engineering. Not all accident reconstructionists are engineers. Do you think there's any advantage to the fact that you are an engineer? How do you look at things differently, maybe?
Yes, well, my first job after I got out of college, I went to work for a road design firm. And there you learn sort of the fundamentals of road design, sight distance, the grade of the roadway, geometrics of the intersection. So that has really helped me when I look at an accident, because I look at those things. Could be what is the sight distance of the roadway? Is the curvature of the road proper? Is the intersection laid out proper? So as an engineer and having that background, I think that helps me when I'm looking at the scene of an accident or things that maybe a normal person would not be looking for. And of course, with the engineering background, you get all the physics. It's not just the physics of accident reconstruction, but you learn all the math, physics, and things like that. That you just get more of an understanding of the mathematics, the physics that go into traffic accident reconstruction.
I think nowadays, I for several years I was taking depositions of reconstructionists that the defense might hire that weren't really that good at reconstruction, but they retired from the police or they retired from some other area and kind of chose to go into that. Some of them weren't even police officers, and some had no background, but they thought, well, this is kind of a lucrative area, so I'll go into that. And the thing that struck me, they weren't engineers, and the thing that struck me was that they would use computer programs to determine things, how an accident happened, the speed and those type of things. But when you actually asked them to sit down and explain to you the formulas or how that worked, how did this computer program come to these conclusions, there were a lot of people who didn't know that.
Yes, that's one of the fallbacks. They give you these powerful programs, but you do have to know the physics that goes into it, that you are inputting the proper data, and that this accident fits the formula you're using. Because I've seen a lot of times they're using totally the wrong formula for this type of crash. And so having that background in engineering does help you understand everything, the physics and the math, and when the formula applies appropriately and when it doesn't, and what factors in the equation really affect it the most. If you have the weight of a vehicle or the angle of approach, what is the key factors that are more critical in the analysis.
And certainly there are other people who have learned that and understand diplomas really well. They're good in math, but certainly the engineering you have to, as part of the, in order to get the degree, you have to understand, and it's, what's going on in the formulas. And I think that certainly gives you an advantage. Tell us a little bit about ACTAR accredited. What does that mean?
Now, I've got my professional engineer's license in Indiana, Kentucky, but I've noticed that a lot of, it's specific to accident reconstruction. It's sort of the PE exam for accident reconstruction, where you take an exam. It's a written exam of 8-hour duration, where first part is I question and answer true and false about accident reconstruction. Then you physically have to work a problem using the old-fashioned techniques, conservation of momentum or energy, to come up with the answer, solve the accident. So it shows your knowledge in the field of accident reconstruction.
And I know that, not all Reconstructionists are accredited through them. Is that correct?
That's correct.
And it's kind of like attorneys. I do semi-rec cases, and I'm board certified in semi-recs, which means that I had to have a certain level of experience. I had to have certain people vouch for me, judges, defense lawyers, experts. And on top of that, then I had to take a test and pass that test. And then, keep up in my area of expertise. But again, not all lawyers are board certified in truck accidents. And so it kind of gives you that extra reassurance when you're picking a Reconstructionist. You can look and say, okay, well, is this person ACTAR accredited? And so you certainly have that. The professional engineer, you're a professional engineer. Again, tell us a little bit about what's required to become a professional engineer.
Okay. Well, I graduated from Purdue University, which was a 4-year accredited college. So after that, you have to, when you got to the end of your schooling, you take what they call the EIT, the Engineering and Training Exam, which is it covers every field of engineering a little bit. So it's a little more difficult class, because you actually took parts of electrical engineering, which I had no classes in. You had to answer questions in that and other fields. But if you pass that exam, then you got to get 5 years experience in the field, and you can apply for and take your professional engineer's license. And that's another 8-hour exam, and continuing ed after that. So
are you glutton for punishment taking all these exams?
Yes, I was glad when that one was over. So
now, so you got a professional license in multiple states. So tell us again, what states got your professional license in?
Indiana, Kentucky, Tennessee, Ohio, and Illinois. I had Michigan, but I don't go up there anymore, and I just let that one lapse.
And let's talk a little bit about, and now you have your own company that you run. In what areas of the country do you work in primarily?
I'm primarily Indiana, Kentucky, or probably 85% of my work. I do some in Illinois and then also in Ohio. I'd say Indiana, Kentucky are a majority of my work.
And I said, I think when I introduced you, that I've had cases where you're on my side, and then I've had cases where you're the expert for the other side. And talk about a little bit about that. Do you do work for both sides of what we call both sides of the V, meaning that you represent the victims of wrecks, as well as trucking companies or the drivers or the truck driver or their insurance carriers?
Yes. When I first went to Donan Engineering, we probably were doing more of the work for insurance companies, and it ended up being a little more defense work. But as I got into the field, I started getting relationships with the plaintiff attorneys and doing more and more work. And right now I probably am a 50% split between plaintiff and defense, what I call plaintiff defense work. And I think it's good to have that mixture, because basically you give an honest opinion. You look at this thing, here's the facts, here's what happened in this crash.
Yeah, and I think a lot of the experts that I use do work on both sides, and I think and you can it seems like it makes you a little more objective potentially. Yes. You're not a hired gun for either side.
Yes. That's almost every time I look at the case now, I know I know the attorneys on both sides usually. So.
Well, and in the same way it's especially in the semi truck area, there's first of all, like there's less than 50 lawyers that are right around 50 now that are board certified in truck wreck law. So I know a lot of the lawyers that do truck wreck cases. And I know the lawyers on the defense side who defend trucking companies. sometimes, I'll speak at conferences where they're at and I'm there. And so we talk and I get to know them. But the same way with experts. I mean, there's a handful of experts that do these cases on a regular basis, and you're certainly one of those. But I would imagine you run into the same experts.
Yes. There's probably about 15 different experts in Indiana, Kentucky, and that I always run into. Know them all quite well.
So what got you into, I'm just kind of curious, what got you into forensic work? And a lot of people, my dad was a psychologist when he was alive, and he treated folks, and he hated it when he'd get called in and have to testify or do a deposition. He was like, man, I don't want to do that work. And so some people just really stay away from it, and other people seem to be attracted to it. Why do you do what you do?
Well, when I first came, my first job was in that road design, and me and my wife wanted to move back to Dubois County where I was from, and there was this firm called Donan Engineering that would, little small local firm. While I went there, they were doing civil design work like I was doing, some road design, some site design, but then they were doing the forensic investigation. And initially it was, I've got a structural degree, structural engineering. We were looking at a lot of houses, just what's causing this roof to sag, what's causing this wall to bow. But then we started getting calls about accident reconstruction. And it's like, at that time, it was only me and John Donan, who was the owner of the company, and told him, that sounds extremely interesting to me. I thought with my road design background and that I'd really like to learn more about accident reconstruction. So I talked to him and sending me up to Northwestern University, where the school is, the Traffic Institute. Started taking classes in '96 up there, and I guess been taking classes. Took I don't know how many hours of classes through Northwestern. And then there's another facility called IPTM, which is Institute of Police Technology and Management out of University of South Florida. They offer courses in accident reconstruction. Society of Automotive Engineers has now come out with very good courses in accident reconstruction. It just always interests me. It's like putting a puzzle together. You try to, take the end results. You see the end results of a crash and look at the evidence that's on the road, look at the evidence that's the vehicle, and try to piece together, the events, what led up to this crash, and come up with the positions of impact, the speeds of the vehicles, the approach of the vehicles. So it's like solving a puzzle using your background in physics and math and training in accident reconstruction.
Well, I know that you obviously do a great job, and it is kind of exciting to put things together and help solve a puzzle. And today we solve those puzzles a lot differently than we did 35 years ago when I started. I could just remember it was a little bit more challenging, to try to recreate and figure out the speed and a whole bunch of other things. And nowadays it's, gosh, whether you're talking about electronic control modules, data that's saved, video. I mean, it's just so much different than what it is. And I would imagine your practice has changed over the years, and the equipment you use, I know, has changed.
Yes. When I first got into it, and we were actually working for the road design firm, I ran the survey crews for the first 3 or 4 years out of college. And we had the old tape measures and levels. We do all the elevation with a survey level and rod. Then we have a crew behind what they call topography, measuring with a baseline offset. And we were lucky enough to have one instrument that would record digital distances for us. So nowadays, gradually, as I got to Donan, we started doing accident reconstruction. We got a total station, which was a great tool, a reflectorless one where you could sit up and turn the angles, shoot distances without having to have a rodman. If you got further away, you needed the prism. But nowadays, everything's getting more and more digital. Like what we used to do with a 6 or 8 man survey crew, I have a drone now that I use with the photogrammetry software Pix4D, where what one person can do what an 8 man survey crew could do in far less time by just putting out aerial targets, shooting the location of those targets, and then flying the scene with a drone. You can create a 3D environment from the photogrammetry using those photographs.
And the great thing about capturing these scenes now, the wreck scenes or accident scenes with 3D cloud point scanning, and yes, is that it captures everything. So if you forgot, down the road, you figure out a measurement is more important because somebody says that this was in the way or blocked their view or whatever. Back in the old days, if we didn't measure it, we might not have it because if the
Yes.
scene was changed, then you're out of luck. But now with these 3D scans, they're so detailed that you've got everything, and you can go back into the computer and figure it out and measure it. It truly is amazing.
Yes, that is a great advantage because you get out to an intersection, there might be tire marks everywhere. You may not shoot everything, like you said. All of a sudden, this mark that you missed, didn't happen to shoot, becomes very critical with the 3D scan or with the drone and Pix 4D. You capture everything, and it's all to scale, and you can measure it from the point cloud or from the orthomosaic that you create. So yes, it's tremendous tool. Plus, you get a great perspective. I like the drone's perspective when sometimes the aerial perspective is one of the best things you can see. You can see tire marks that really might be more difficult to see on the ground.
Yeah. Well, I know you and I are working on a case, and I won't go into detail about it, but it's kind of cool because it's a case where unfortunately it's very tragic, but yet figuring out what happened, why it happened is still part of the job. And in that case, you used your drone on the outside of the building. But then we also did 3D scanning inside the building through a company called Precision Point. And so it's fascinating to me that, if you get hired quick enough and you can preserve the scene through the outside and the inside of, if it's a case involving a building, in this case, a vehicle went through a building. But it's amazing the amount of information and data you can collect on the front end of these cases now.
Yes. That's very critical in a lot of these cases because you get the cases that are 2 years old and that data wasn't collected, and you're trying to work off photographs that were taken by someone that's not really trained in reconstruction. And, the more data, the better job you can do, the more pieces to the puzzle you have. So.
And I think that's important. And I think, again, in this podcast, I speak to lawyers and I talk to lawyers and they get it. But on the other hand, this podcast really is designed for just ordinary folks who have a case and they're wanting to know things. And I believe that if you give them information, it kind of empowers them. So regardless of who they hire, who their lawyer is, they know, okay, guys, I ought to ask them these questions. And one of the things that is how important is it to preserve evidence? I mean, so when people are sitting there and their attorney may not be talking about preserving evidence, that's one of the first things that I do. I mean, I understand it. I get it. I've seen what happens when lawyers hire me 2 years later and the data is gone, and the information is gone. But just, for these average everyday folks that are listening to this, talk to a little bit about how important it is to be able to get there quickly and preserve the evidence.
Yes. Well, the scene work I'll start with because, a lot of crashes, the officers that are investigating this are not trained reconstructions. They're there just to, fill out the report, make sure the people are safe and taken care of health-wise, get everything cleared off the road so they can open it up. But they don't know what's really critical when it comes to traffic, to figure out what happened in the crash. So a lot of times I'll get the scene photographs that were taken, and all the photographs first one will be the license plate of the car because they want to identify that for their report. And then they'll take photos around the car where they're at final rest, and all right, the crash was over, down here 100 feet. We don't have a single photograph there. So you need to get out there and, make sure you've documented the evidence. So if a new crash, I want to get out there within a day or two after I get the assignment to get out there as soon as possible in case tire marks fade, gouges disappear. Sometimes I've had roads get repaved totally. And then even if you have photographs, you can't really, they have no survey data. You can't reestablish the evidence as well because you use sometimes like a dash white line or a reflector here. I can reestablish where that evidence was at using some photographs. But so the sooner you get out there and can document all the evidence as soon as possible, all the tire marks, any gouges, fluid, where it's at, ruts that were created, the more you have to do a better job reconstructing the crash.
Yeah.
And then same thing with the vehicle. Like you said, the vehicles now have electronic data. So being able to get to that vehicle before it's destroyed, get the data that might be in the vehicle, get actually good pictures of of the vehicle, of where the damage is. What they call the contact damage was where the two vehicles are physically in touch. You want to document that area really well. The induced damage is crush that's caused by not necessarily direct contact, but because there's so much deformation, it's pulling other parts and displacing other parts. So seeing the vehicles getting good documentation is vital to do a better job in reconstructing the traffic crash.
And I think if the people are listening, if the people who are listening to this, that if nothing else, they learn from this. I mean, they should, if they've been in a catastrophic wreck or someone's been killed or it's a serious injury, they should contact a lawyer that knows what they're doing as soon as possible. And they should be asking them, do you have a team that can get out to the scene and lock in this evidence and preserve this evidence? And are you planning on sending what we call preservation letters out to the defendant so that they know to preserve the vehicles, preserve the scene? And if your lawyer is hesitating and doesn't know what you're talking about, then you may want to consider interviewing a different lawyer, because as you said, it can affect the puzzle. If you don't have all the pieces, you don't know what the puzzle is. And I see that all too often where people just, and even in cases where I've had cases where, they said, well, guys, it was the cars at fault or the semis at fault. It's clear. And so we don't need to do any of that. And then later they find out there's a defense or there's something raised or they blame somebody else. And that evidence is long gone. And, the ability to disprove something is gone. So I hope people listening to this will at least, ask their lawyers, hey, what are you doing? And expect them to get the right team and hire the people. The clients don't have to pay that up front. It comes out later. So the lawyers should be investing in doing that. And I'll give you one example of construction zones. I mean, I get every year construction zone, people die in construction zones and big rig semis hit them. But construction zones change. They're so dynamic that if you don't get hired quickly, boy, you're really behind the eight ball.
Yeah. You want to make sure they got the appropriate signage and, the cones and barricades where they're supposed to be. And so, yes, you want to get out there because right after the crash in 2 or 3 days, they may be moving down the road and totally change all the signage and everything. So it is on those construction zones. It's very vital to get out there as soon as possible.
Yeah. And we'll 3D scan the scene of the wreck, in a construction zone, but we'll also use 3D scanner that go out and actually run. We put them there on the back of trucks and they run them back and forth up through the lanes. So you can actually follow the path of the vehicles and capture the road and the turns and all the sign. I mean, it's just amazing what you can do if you get hired quick enough. So
yes, the scanning has really changed the industry for the amount of data you can collect and preserve very quickly.
Yeah,
it does take enormous computers nowadays with all the data, but
it's true.
Yes.
So let's talk a little bit about the. Nowadays, we alluded to it, but a lot of vehicles, most new vehicles have data that can be extracted from the vehicles, the semi-tractor trailers and the cars. And so let's talk a little bit about, and as more older vehicles are disappearing and getting replaced with newer ones, I'm seeing fewer and fewer wrecks that there isn't some type of data. So talk a little bit about that and what kind of data, how is it stored? How do semis and cars have this stuff in them?
Okay. I'll start with the cars because they were the first, I think, vehicles that started recorded data. And that was the airbag module system, or the airbag system is what records data on cars. The airbags are designed, so it's amazing the technology that goes into design because a typical severe crash lasts a tenth of a second. Just 0.1 seconds. And for an airbag to be effective, they have to be deployed within 0.04, 0.05 seconds. So the airbag system has to figure out, how fast is this car seeing the onset of the crash? Is this a crash we need airbags? Does the driver have a seatbelt on? Where is the position of the seat? So the technology, how fast they make these decisions and get airbags out is incredible. But one of the benefits is that if it wakes up the airbag system, the brain of the airbag system, they call it the airbag control module, does record data now. And It records typically, it used to be the old GM was the first manufacturer that they started recording in the late 90s, mid 90s. You get 5 seconds of pre-crash data, which was vehicle speed, braking, if the brake was service brake on, off, engine RPMs. You get that data for every second for 5 seconds of data. And Ford was the next one, started coming in, and they started getting more and more data. And so now we're up to, I'm not sure what percentage, it's well over 90% of the cars manufactured in the US that have an airbag system. The federal law is now they have to record data if they've got an airbag system. So, but you'll get a GM, or not GM, but Chrysler, they were one of the ones that started recording steering input as well and getting a tenth of a second data. So that was the first data, is the airbag system wakes up, or even then, if it just wakes up to evaluate the crash, doesn't have to deploy airbags. If it just wakes up, you'll still get crash data. And you not only get the speed.
And how do you get that data out? I mean, so so this car crashes, and let's say airbag goes off, or that airbag system is woken up. Yes. I think people are like, well, how in the world do you find out what it says?
If you're lucky and it's not too badly damaged, the easiest way is under the electrical communication port under your steering wheel normally, the DLC. You can go to that and plug into it with your computer. And if you got power to the module through that system, you can download the data using, it's called the Bosch CDR software and system. And you can access the data. If it's too much electrical damage, you can go locate that airbag module, which some of them are under the driver's seat, under the passenger seat, or somewhere in between the seats, either up under the dash or all the way back immediately between the seats. So you locate the module, do the download in the car, and you've got cables. Each module, the manufacturer makes cables for certain cars. So you connect your cable to the module and the same software, and you can download the data that way.
And nowadays with cars, they have a lot. They have crash avoidance stuff. They've got. It's amazing the stuff that mirrors light up if there's somebody in the blind spots. You've got a whole bunch more people talk over the phone, or they have Bluetooth technology. So I would assume it, and I don't know how far along are we. Is that information helpful? I mean, can you find out, like, if somebody's swerving over the lanes, the cars vibrate, they do a variety of things. Is that information preserved at all?
You get it. Now there's this infotainment center data you can get, which will give like turn signals and door opening and all kinds of data. And there's additional data that's not really accident reconstruction related that you get as well. But it's amazing the data that the infotainment, anything, if you're using the GPS following a GPS. So there is tremendous amount of data that you can get from a car using those systems to download. So it gets into a proprietary, I guess, in the criminal case, you can use all that and get that data, but as accident reconstruction, there's a lot of data that might be protected, but there is data there.
And semi, obviously I do a lot of semi-tractor trailer cases throughout the country, and certainly the amount of data that's available now in those semi-tractors and the trailers is a lot more than when I first started. So talk a little bit about what kind of data is there and how do you extract that?
Yes, you get data. Well, the initial data was usually coming from the ECM data. It records the hard brake event data is what they would call it. On the semi, the airbag system is not involved in this. It's the engine control module on a semi that records data. So a lot of the newer semis are set up to record what they call a hard brake, sudden decel event. They each call it something different, but it records if the level of braking reaches a certain level, usually 7 to 9 feet or miles per hour per second deceleration, somewhere in that range. If the driver applies the brakes and decelerates at that rate, it will record that event up to 60 seconds of data, like a 1 second. And then 15 seconds after the event, it records data. So that was sort of the initial data we were getting from a lot of semis. And of course, the ABS system also provided some data. You usually didn't get as much data out of ABS unless there was a fault or some kind of failure in the crash, and you get spot speeds at that point. But now it just keeps evolving. It's hard to even keep up with what all is being recorded by semis now, with the crash avoidance systems and cameras that capture video and crash avoidance, and speeds that you can get from the crash avoidance. And the ABS now is also starting to record more and more data from crash events. You can send the information in now, which we didn't know in the past. If you downloaded the data off the ABS, you now could send that in. Now, fortunately, it's taking a year to get the data back, but they actually had the technology to interpret that and give you steering and braking and everything. So that's becoming more prevalent. So the technology and it just keeps evolving. I think everybody, you see more and more cameras being employed by truck drivers and systems. They drive cam systems. I mean, they'll show what the driver's seeing forward, sometimes what they're seeing in the back, and what the driver's doing inside the cab is being recorded in these incidents.
Yeah. Well, in other commercial motor vehicles like buses, and you see videos that are most buses will have some type of video stuff, and semis is more and more common to see. Certainly, cameras looking outward. You see them looking back at the driver as well. I've got cases where we see both. But I know that getting, again, preserving the evidence. Sometimes these semis are not totaled. They can kill somebody and still drive away from the scene. What happens when they drive away and they have other brakes? Does the semi, I know the answer, but the semis will, can they record over that?
Certainly, yes. The hard brakes, they usually can store at most 2 hard brake events. And if the driver's going down the road and has another incident where he hits the brakes hard enough to record, it's going to overwrite that prior event. And so, yes, that data it's not recorded or downloaded immediately, and they allow the truck to continue to drive, that data can be easily lost pretty quickly.
That's another reason why we send out with these preservation letters to say, please don't move the vehicle. I mean, because oftentimes the police, sometimes if it's a fatality or a bad wreck, they may impound the vehicle temporarily. Yes. Now, unfortunately, what they're doing usually is just like a level 1 inspection. They're not doing anything in a lot of detail. Sometimes they don't even have the equipment to download anything. Mm-hmm. But you send these preservation letters out, so you try to get somebody like yourself in there and do the downloads before they drive that vehicle again and have another hard stop, or intentionally or unintentionally.
Yes.
And they're not easy. I've seen you and your dad literally have to tear up a semi-tractor trailer or semi-tractor to try to get to that data. So where is this? How do you get the data out of these semis?
Well, like the other ones, you're fortunate if it's not badly damaged, you can plug into the under the dash again, to that and download the data. But unfortunately, some of these are pretty severe crashes. You actually pull modules and have to ship them off, possibly to get them downloaded. And I know, like Detroit Diesel, some of them have, you've got a module on the engine you got to remove. You got another one that the speedometer is the instrument that you have to pull out and send in. And then there's the module in the dash itself. That's the hard one to get to. That really has the best data. And so you usually you get your hands dirty and usually have a lot of cuts and bleeding when I'm done. So,
well, and I know that, when we do these, you hire a reconstructionist like yourself that kind of oversees and kind of gets all that information. But then another part of what we do is, you'll often suggest, or I'll volunteer to have a mechanic there as well, because again, you get one shot to look at these vehicles. And so, I know recently we had you and a mechanic. I've used a mechanic and you and Reconstructionists multiple times, where they're looking at it. Are the brakes working properly? Is the engine running? Different types of things. Is the accelerator sticking? Whatever. So I guess you, as a Reconstructionist, you kind of work with other people sometimes to try to figure these things out.
Yes. Yeah, a mechanic is I've got a mechanic I work with quite often. been a diesel, he's a regular mechanic from a lot of his life, preparing passenger cars, but then he moved into running a diesel shop and repairing heavy vehicles. I consult with him quite a bit and use him on the cases where I think there is a mechanical issue with the truck or the car or tractor and trailer that we need to look at and thoroughly evaluate. And so, because that's the one thing, I'm an engineer. If I could go back to high school, I probably would have took more automobile mechanic classes, because I was doing all the math and physics and not the mechanical part. So,
when I know the guy that you like to use, Gary, he's been a guest on the podcast as well, and kind of talks from his perspective how things are different and what he looks for and what he does. But yeah, I mean, it's a team effort. I mean, depending on what kind of case it is, sometimes I have investigators going out trying to talk witnesses and get witness statements that help fill in the blanks. Sometimes we talk to the police, and you've got reconstructionists and you've got mechanics, and phone downloads, I mean, has become a big part of, there's download information from the phone. So
yes,
there's a lot more, there's a lot more there.
Yes. It's never ending.
Well, let's talk a little bit about, one of the things I want to talk about today is stopping distances that, I think semi-tractor trailers and cars, I mean, sometimes I see people driving on the highways and they cut off semis. Yes. And I don't think they realize that these semis just can't stop on a dime. And I was hoping maybe you could educate people a little bit about stopping distance, what's in, and on semis and cars. And I guess, first of all, what factors are involved in determining how quickly can a vehicle stop?
Yes. Well, there is a big difference between a semi-tractor or a passenger car, and motorcycle is another unique vehicle when you're looking at stopping distances. The passenger car is probably going to be the easiest as far as it uses hydraulic brakes, and you don't get any real delay in the brake system when you apply the brakes. And we got pretty good established braking, charts and stopping distances for cars. But a semi, they are a heavier vehicle, and a lot of people think it's the weight alone that causes, the greater stopping distance. It does go into play of how much force and work you have to do to stop that vehicle, but the brake systems are sort of designed to handle that work and be able to handle the heat that's generated. But probably the biggest thing that causes the bigger stopping distance on a semi is there's two things. The tire composition on the truck is a harder rubber. And they make that because trucks, they carry such heavy loads, they need to get about 300,000 miles out of each set of tires. And so they got a heavier tire, or harder rubber that doesn't generate as good of friction and traction as a car tire. So that reduces their drag factor capabilities. And the air brake system, it's great for semis, but it does have air brake lags in it. So those two things combined generally make the trucks, at least 1.5 almost times greater stopping distance than what you have with a passenger car. So yes, you need to allow those truck drivers, space. You can't cut right in front of them because they can't stop as quickly as you. They need to maintain a proper following distance for the same reason, because if a car stops suddenly, they can't match that car stopping. So it is, the stopping distances are quite different. It is, in fact, go ahead.
I'm sorry. So, and what is, I mean, I get, and you alluded to it. I mean, I think a lot of people probably think if a semi is fully loaded,
yes,
and is carrying its maximum weight that it's allowed to, that it is harder to stop. It's going to take longer to stop than a semi that is empty, that's running empty. And that's not necessarily true, is it?
No, it's actually the opposite. It's actually probably best to have a load in there and weight on the tires, and because that's what you're generating friction between the way you stop the vehicles. The momentum's keeping it going. It's weight and velocity in the one direction. To stop it, you got to put a force in the other direction, which is generated by the friction that can be generated between the tire and the roadway. And the more weight, the more friction that can be, and resistance force stop that momentum. So it actually helps to have weight into trucks and in trucks, and the less weight, the less resistance you get from the friction. So to a point, I guess you don't want to overload trucks, because then the components, if they're sustained braking, they overheat and start losing some of their function or their ability to stop. But yes, it's actually better to have a loaded truck than to not have a load in it.
And so, and again, make sure I understand. So one of the reasons that a car can stop quicker than a semi is that they have different types of brakes. Is that right?
The tire composition, I think, is the biggest component. The car passenger tire just grips the road better, and that's what you're looking for, that friction that develops between the road surface and the tire itself. So they generate, like on an asphalt road or concrete road, you can get 0.7, 0.8. They call it G's, or friction factor, where a semi tire, the best, probably gets about 0.5 to 0.6 because of that's one of the big factors. And then that air brake lag time, where you don't see that in a car. You apply the brakes, you pretty much get quick response, where getting the air to all the systems and getting everything functioning, there's usually a third of a second to a half second air brake lag, where you're starting to apply the brakes, but nothing's really happening until it gets that force generated.
And I would assume that the road surface, when you talked a little bit, I think some people may have heard the word drag factor or whatever, but certainly the road surface has an impact on the stopping distance as well. I would assume if the road's wet, if it's gravel, if it's ice and snow. I mean, talk a little bit about the road surface, how that affects the stopping distance.
Yes, it is that friction that you're wanting to develop between the tire and the road. Of course, having a dry asphalt or concrete with fresh new asphalt, that's where you probably get your best friction, where the tire can generate that retarding force to stop the forward momentum of the vehicle. If you get into a rock, well, you don't have that. The rocks will slide on each other. You don't get near the friction and resistance that you would on a hard surface like asphalt or concrete. But then you start throwing a wet pavement in, you're taking away some of that friction that can develop. And so your drag factors go down. It's the longer stopping distance on a wet pavement. And ice, you really substantially lose. Ice or snow, you just aren't developing friction between. It just slides. The tire will slide on that surface and have very little retarding force to stop the forward momentum, the weight and speed of the vehicle.
Well, and every state has a commercial driver's license manual that truck drivers have to study and pass to get their CDL. And, in that, under most states' CDL manual, it will say that a semi-tractor trailer, if it's on wet pavement, it should decrease its speed by a third. If they're driving on packed snow, they should decrease their speed by 50%. And if they're driving on ice, they need to get off at the first safe opportunity. And I assume that the reason they're decreasing speed is that help then the stopping distance on those bad surfaces?
Yes. I mean, with the weight of the semi, that the momentum they have is tremendous, because you're looking at 60, 70,000 up to 80,000 pounds. If it's going 60 miles an hour, its momentum is the weight times the speed. So you got that much momentum going, where a passenger car might be 5,000 pounds at 60. Well, if you do the math, it's probably 16 times the momentum, or I didn't do the math yet, but you got greater momentum with a semi. So trying to get that stopped, is going to take, if you have reduced friction, it's going to take substantially greater distance, and you're not reducing that momentum. And that's really the key. What's really critical is what causes severe crashes is the momentum is, the speed and the weight is what is critical in a crash. They can do more damage and you end up with fatalities the greater the momentum.
And I think it's helpful for people. You provided me with a chart, and we'll put that up for folks to look at, but maybe you can kind of go over it at the stopping distances for large trucks. So the folks will be able to see that. Can you kind of walk us through that chart and what it means?
Yes. Yes, that one shows, various speeds, what the stopping distance is for a semi versus a car. And they start at 20 miles an hour. Now, part of the stopping distance is the person in the vehicle. So they've allowed a perception distance that's on the chart, which is, on this instance, they use 1.75 seconds for the person to perceive that they need to apply the brakes and then there's another distance that they've got is reaction distance, which is the physical movement of their foot from the accelerator pedal to the brake pedal. So that's a 3/4 of a second. So those two add up to the 2.5 seconds that the vehicle's not slowing at all. It's continuing at the same speed. But then they have the braking. Once the brakes are applied, here's the distance from 20 miles an hour. It takes a semi to stop, and 20 miles an hour, it would take a passenger car to stop. That's the slowest speed, and it shows on that chart 103 feet for the semi from 20 miles an hour and 92 feet for the passenger car. So it's not that big a difference at those speeds. But if you start looking up higher speeds, get up to the interstate 70 mile an hour speed, and you put in there the distance for the semi goes all the way up. The braking part goes to 490 feet, where the passenger car is 233 feet. The other two stay the same. So you get a tremendous difference in the semi. And that's that combination of having the momentum, trying to stop the vehicle, and the air brake lag time. So it's those tremendously, the semi just with the higher speeds takes a greater distance than does the passenger car. And
I think that the chart is helpful. The chart shows, the from 20 miles per hour, 30 miles to 55 and then 70. And, what people will notice on that is what we call perception reaction time. It's going to be the same for the semi driver and the car driver. I mean, they're going to take them the time to perceive that I need to stop. And then it's going to take time to get your foot down the brake and actually take some steps to do something. But then you can see, like you said, the faster you're going, the harder it is for them to stop that semi.
Yes.
And that's something you need to be aware of if you're sharing the roads with semis, which nowadays we're sharing roads with lots of semis.
Yes.
And so I think people need to be aware of that. So anything else on stopping distance that you think would be helpful for just the average person to know when they're out there traveling on the highways?
Yeah. One we didn't really talk about a vehicle is a motorcycle, because that's it's a unique one, because you have two separate braking systems on a motorcycle, where the driver, it's really the skill of the operator comes into big play on that. And because it's typical, you've got a rear brake you apply with your foot, and then you got a handbrake which controls the front wheel. And so they're two separate systems, and the skill of the rider really comes into play, because if you in a crash on a motorcycle, you don't want to jam on the front brake and lock the front wheel, because then you lose all control. The vehicle will end up falling over because you've lost your stability. So a skilled rider really has to know how hard to apply the front brake and the rear brake combined to stop. So it's totally different, stopping system, and it's very skilled oriented stopping.
Just out of curiosity, is there data in a motorcycle that you can download?
They're starting to look. I know Kawasaki is now starting to put a data recorder. I think they're the only one I'm aware of yet. Maybe some of the other high end we haven't heard as much yet, but I think it's coming, because that was the one. Motorcycle crashes are about the hardest to do, because the old traditional math you use, momentum and energy, don't really apply when you have a 600-pound motorcycle crashing into a 5,000-pound car, or even a larger vehicle. The momentums are so much different. The motorcycle has no momentum, so it makes the old traditional math, hard. So if they could get the electronic recording in the motorcycles, I think that would be tremendous benefit to the accident reconstruction part of it.
And along those lines, sometimes even when you have all this data that's available in vehicles, I still get cases occasionally where there is no data. For example, I had a school bus that hit a pedestrian, and they had not activated. It was disconnected, and so there was no data in the ECM. Yes. I had a box truck that the company had chose not to activate their system. So there was no data. We had Reconstructionists look at both of those, and there was no data in either one of those vehicles. And so we had to come back and try to figure out the speed of those vehicles. And I know you've done that as well. Some nowadays we see security cameras all over the place. There was this in the bus case, there was a security camera that would look back towards the kids on the bus, and we knew the route. And so we were actually able to get out to the scene quick enough that we could go by the shadows.
That was my case.
Yeah. And we could recreated that, yes. Right? And so we could determine speed by something that was really unique, because there was no download available on the bus because it hadn't been activated, but we used shadows to show and determine speed. And I've had other ones where we've used security videos to look at things that measure things. Talk a little bit about that. I think you had a case where you've had to do that, or you've had multiple cases. You did work on the bus case and you worked on other cases.
Yes. That is, like you said, the security cameras are everywhere anymore. And I had a case, really interesting one, probably about a year ago, that it was 3 vehicles that were involved approaching on, 2 of them were on the one street approaching each other, but another one coming in from a different direction. We got videos from 3 different angles of the vehicles approaching the intersection. One of them caught all 3 vehicles approaching, and we were able to get that video and break it in to figure out how many frames it is per second in the video, break it into a frame by frame. And then when I go out there, with my survey equipment, I located that camera and I shot the location of the camera, and then objects that are along the road so I could figure out where the front of this truck passed between the line between the camera and the power pole that's behind it. And then another 80 feet down the road, 100 feet, the front of the truck passes between the camera and it was a canopy post on it. And knowing, all right, he's driving down this lane of the roadway. I know the distance he traveled from when the front of the truck passes this line to that distance. And we know it's so many frames per second of video. So you count how many frames and you have distance and time, you can come up with the speed that he traveled during that distance. So we had this on that case where we had both the ECM download. We actually got the download, and from all 3 vehicles, we got data, and we had camera views. So we could step by step, and it matched up perfectly with the data from the downloads. But this one was particularly of interest because there was a vehicle that its nose came out from behind the corner of a building, and we were trying to evaluate, was there any delayed response on the one driver's reacting to it? And you could start step by step, say, all right here is where the nose of that car first become visible, and when did we start seeing him respond? So it was a very powerful tool.
I know you sent me a picture. Was it the truck with the black back on the white truck?
Yes.
Black, and so you were measuring that as it went by the different things and that.
Yes, yeah, it was the nose of the truck. It was a dumpster truck that was coming into view. You could see it pass by that power pole, and then a little bit further down the road. So we knew his speed from that video, and it did compare almost identical to the speed that was obtained from the download.
Well, I think that's, it is fascinating. I think that's why, again, preserving evidence quickly so you can, have those measurements, look at that. In the case I was talking about, the box truck, it didn't have anything, but it drove by a car lot. And so the car lot captured it. So we were able to break it down by frame and see that. But, sometimes security cameras don't keep that stuff very long. So if you don't get it, you're out of luck, and if there's no download. So,
yeah, I had a case recently where the driver was driving without headlights on. He just had his running lights at night, and we got the security camera on that case. And you could tell other cars come by and they have their lights fully on, and he drives by and it's like his lights aren't on. We have no other way of reconstructing that, but we got that security camera. It was a pedestrian hit and run, and we figured he didn't have his lights on, and sure enough, he went around the corner and went through the security camera, and he did not have lights on. So
Are you seeing more security camera, like whether it's DoorDash or out, even on pole barns? Am I got out in the middle of nowhere? I mean, are you seeing more of that?
Yes, it's nearly almost every crash anymore. That's one of the first things I look around is there any security cameras here? Houses or businesses, they just seem to be everywhere now. So yes, it's seeing more and more.
Anything else, Steve? I appreciate you taking the time to talk to us on this podcast. Anything else that you think ordinary folks that are out there that unfortunately have, had a loved one killed in a serious wreck or had some themselves or someone else seriously injured? Anything else that you could think of that they need to know, from a reconstruction perspective?
Like you said, you do want to get out there and document all this stuff as soon as possible, because that's how you reconstruct. Is the more pieces you have to the puzzle, the more I can help, and determine what happened and what the speeds were. Like you said, get a good attorney that knows to get this stuff preserved. Because with all the electronics in cars, there's a good chance that the newer cars will have data. If you let that be destroyed, that's evidence it's gone. It can't be gotten back. Like we talked about the scene. So the sooner you get the evidence, the more you document the evidence, the more we can help.
Okay. Well, I appreciate it. I know that the first question clients ask me is, why did this happen? How did this happen? And like you said, the sooner I get hired and I put a team together of people like yourself, reconstructionists and mechanics and private investigators, to look for security cameras, look for video cameras, the better my job, the easier it is for me to answer that question. And that's that's the question they have. So, well, thanks again. I appreciate it. And this will end this episode of After the Crash.
Thank you.